In today's video, we're going to go over the new UniFi 6 outdoor mesh access point. UniFi products have been challenging to get a hold of lately, but I was lucky enough to buy one of these. If you want to know more about this product, then stick around and watch the rest of this video. And if you find this video useful, please give it a like and don't forget to subscribe. I've been a UniFi user for many years, and last year I upgraded my access points to all the UniFi 6 versions, and I've been super pleased with the results. The one thing that was missing, though, was an outdoor access point to provide better coverage around my backyard and pool area, as well as the ability to connect to my outdoor devices such as pool pump controls. Before we get into the configuration, mounting, and testing, let's take a quick look at the hardware and see what comes in the box, as well as review the different mounting options that they provide. In the box, you get an access point, an 802.3 AF PoE adapter, as well as a wall, desktop, and pole mount mounting options. You can also purchase a separate ceiling mount kit if you need to mount this thing in a ceiling. Design-wise, this thing is really well thought out, giving you an easy way to configure your mounting needs just by swapping out the base. For the pole mount, they also include tie-downs to simplify mounting the device. Given the size of some of the other UniFi access points, this device is actually really small. As you can see, sliding the different base options is pretty easy. Out of the box, it comes with the desktop base installed, and once you slide it off, you can install different inserts such as the wall mount adapter. Let's go through mounting using the pole mount, which is what I intend to use in the actual application. Unlike the other mounts, the pole mount actually has two parts. You first have to feed the Ethernet cable through the wall mount adapter and then plug it directly into the access point. Once you plug in, you have to carefully bend the Ethernet cable down towards the base of the unit so that you can slide the wall mount in place, which causes the cable to point downwards. To finish, slide the pole mount adapter in place and you're all done. One note is that certain Ethernet cables with large cable boots may have a little bit of a challenge making a bend that tight. So you might want to test fit it first before doing any cable runs or any kind of serious mounting. As you can see from the video, using the tie wraps, the access point is mounted on an electrical conduit attached to the side of my house. Though this item is marketed as either an outdoor or an indoor access point, one thing I did notice about this thing is it runs really hot. In an indoor environment with my room temperature about 75 degrees Fahrenheit, the outer temperature of the access point measured 127 degrees Fahrenheit, making it hot to the touch. I have yet to see a device that can sit on a desktop measure that hot. This may not be a problem and well within the design parameters, and because of its size, it may be transmitting more heat to the outside case than other products. But as I live in Southern California, I'm truly interested to see what happens and how hot this device gets sitting in outside temperatures of 100 degrees Fahrenheit. I did go back and check on the temps after it had been running for a while. With an outside temp of about 84 degrees Fahrenheit, it seemed to actually run cooler outside. As you can see, it ran significantly cooler than it did on the inside temperature. I'm still concerned when the temps get above 100 degrees. But it appears that being outside with a little extra air circulation seems to help. I'll keep an eye on it over the summer. Hopefully this won't be an issue. So let's walk through the setup and see how this thing performs relative to other UniFi 6 access points. After you power up the access point, you can now see that it appears in the UniFi controller and is ready for adoption. It will automatically do a firmware update if there's one available, and then finish off the adoption process, adding it to your network. For this particular access point, as I'm mounting this outside, I want to make some changes to my access groups. I want this access point to belong to its own group, as it will be the only device connected to my IoT network at this time. To do this, I'll edit the IoT Wi-Fi network and create a new group and assign this new UniFi 6 mesh access point to my IoT network. If I edit my IoT network, you can see the current access point groups that I've created, and I'll need to create a new one. I'll call it outdoor and assign it to the IoT network, which currently only contains a single access point for now. Once we're done, we can save the changes, and we're now ready to test this thing. To establish performance, I used iPerf and speed test. I tested at 5 GHz using the LR the UniFi 6 LR, and this device. I tested both at approximately 40 feet away with no walls and virtually direct line of sight to both devices. Looking at the speed test results, you can see that the UniFi 6 mesh doesn't come close to the performance of the UniFi 6 LR, despite both being a 4x4 multi-user MIMO. I repeated these tests numerous times and got the same results. It's not that the performance is bad, I just want to point out that it's actually slower than the UniFi LR. Jumping over to iPerf, the story remains about the same, with the UniFi 6 LR consistently faster than the UniFi 6 mesh unit. One thing to keep in perspective is that this is a new device which will possibly get some updates that may optimize it in the future. Though not as fast as the LR, it's still a really fast device. Overall, I'm pretty pleased with this, and my only concern will be long-term reliability of the device based on the heat it appears to generate, and that still remains to be seen. Anyway, that's about it for today's video, and if you found it useful, please give it a like. Don't forget to subscribe and hit the notifications. Thanks for watching, and I'll see you on the next video.